A true IMAX screen occupies your entire peripheral vision, replacing the dark of the theater with high-fidelity light. While the brand is synonymous with premium ticket prices, the image quality depends on mechanical and optical systems that operate at the physical limits of analog film. Standard widescreen theatrical presentations use a 2.39:1 ratio. The native IMAX format expands that frame vertically into a nearly square 1.43:1 aspect ratio. This vertical expansion creates a massive capture area. A standard 35mm frame provides roughly 465 square millimeters of image, whereas the IMAX frame offers 3,375 square millimeters. This surface area yields a digital equivalent of 12,000 to 18,000 horizontal pixels. Rather than simply scaling up digital projectors, IMAX achieves this resolution through a mechanical reorientation of film transport and optical physics. To understand this system, we must examine its mechanical transport, the optical consequences of its size, and the resulting economic scarcity of the format. Achieving the maximum image requires operating at the absolute physical boundaries of analog technology. For over a century, the cinematic standard involved 35mm film running vertically through a camera. This vertical orientation presents a physical bottleneck. The image width is constrained by sprocket holes, with further area dedicated to the optical soundtrack. IMAX bypassed these limits by rotating the film 90 degrees to travel horizontally through the gate. This horizontal transport allows the frame width to be determined by the length of the strip rather than its gauge. Each frame is 70 millimeters high and spans 15 perforations in width. Because the audio is handled by a separate synchronized system, every square millimeter of the 1570 negative is dedicated to image capture. This unique geometry creates the 3,375 square millimeter surface area that drives the format's 18K resolution. Projecting an image of this scale requires specialized heavy projection equipment. Standard projectors use a mechanical claw to pull film intermittently at 24 frames per second. However, the mass and inertia of a 1570mm frame would cause the celluloid to tear under that specific stress. The film must travel at 337 feet per minute to maintain a standard frame rate, compared to the 90 feet per minute required for 35mm. The engineering solution is the rolling loop mechanism, an invention by Peter Ronald Wright Jones. This system moves the film in a continuous wave-like motion rather than a series of jerks. As the film enters the rotor, a rotary air valve pulses jets of air that force the film into a loop. This loop carries the frame past the aperture, where it is secured on fixed registration pins for a fraction of a second. Simultaneously, a vacuum system sucks the frame against a glass field flattener to ensure absolute flatness and focus during projection. The rolling loop is a mechanical necessity. Without it, projecting an image of this mass at cinematic speeds is physically impossible. The physical size of the large format negative dictates unique visual characteristics. Lenses behave differently when required to project light onto a massive capture plane. On a standard 35mm camera, a 50mm lens approximates the perspective of the human eye. On a 1570mm camera, that exact same lens provides an extreme wide-angle view. To capture traditional wide perspectives, IMAX cinematographers must use lenses with much longer focal lengths than standard equipment requires. These longer focal lengths inversely compress the depth of field, blurring the background while the subject remains in sharp focus. This allows the format to capture 120-degree lateral fields of view while maintaining a shallow depth of field, creating a heightened sense of dimensionality. Operating at this industrial scale generates significant mechanical and financial friction. The sheer mass of the equipment means filming is dramatically slower and more expensive. Because the 1570 format consumes film at 4 times the speed of 35mm, a 1,000-foot reel is exhausted in 3 minutes. Stock, processing, and scanning costs reach up to $15,000 per minute of footage. Hardware scarcity adds further cost. Only 8 to 9 true 1570mm cameras exist worldwide, commanding rental fees of $16,000 per week and requiring $1 million in insurance. There is also a severe acoustic limitation. The mechanical power required to drive the rolling loop makes the camera sound like a chainsaw. This noise level makes it impossible to record clean dialogue on set. Filmmakers must either rely on studio dialogue replacement in post-production or switch to quieter 5-perf 65mm cameras for dialogue-heavy scenes. The 1570mm image is gatekept by this extreme friction, making it a format reserved for the most highly capitalized productions. To maintain the brand ecosystem without using 1570mm film for every release, the company utilizes digital media remastering, or DMR. This process uses proprietary algorithms to analyze every frame. It removes digital noise and sharpens details, so the image can be projected onto an 8-story screen without visible artifacts. Recent years have also seen the certification of digital sensors, like the 8K Sony Venice or the Fujifilm GFX Eterna 55. While these are silent and practical, their resolution still trails that of 1570mm film. In 2022, the company announced the second generation of 1570mm film cameras, nicknamed the Keeley, to address these limitations. These models utilize aerospace materials like carbon fiber and titanium to reduce the 240-pound weight of the original fleet. The internal transport is also being redesigned with vibration-dampening materials to reduce noise by 30%. This development is supported by filmmakers who prioritize the analog format, most notably Christopher Nolan. Directors like Jordan Peele are also collaborating on the development to ensure the hardware meets modern production standards. Christopher Nolan's The Odyssey, slated for 2026, is reportedly the first theatrical movie to be shot entirely on these quieter IMAX film cameras. As aerospace materials reduce the friction of the 1570mm ecosystem, the specific optical properties of analog film will remain the definitive standard for premium cinema.